Hi, this is the Lab 8 presentation for the EE178, and we decided to go with the elevator. The group members are myself, Ramandeep Jagdev, Sebastian Charles, and Andy Tran. The task at hand is we were required to implement an elevator using FPGA, and we did this with a non-floor based FSM as required. The benefits of this include it is scalable, it's easier to implement, and it gives the designer of the FPGA complete control of it. And a quick explanation for this is we start off at the idle state right here, and then just how we normally go into the elevator, what floor we want to go to. And then for the next step is the elevator gives us a response. And as we enter the elevator, it either decelerates or accelerates. Newton's second law of force is equal to mass times acceleration. In order to lift lift an elevator, obviously you need to accelerate a little bit, which is why we feel that initial jolt. And if we're going down, we got to decelerate because we're going into gravity, and you don't want there to be too much of a sudden drop. And then eventually we reach the floor requested, and we announce the floor number, as we did in, I believe it was lab 3. And then there's a double check. There's a delay for a double check to make sure you're in the right floor. Then the door opens, and then it remains open, and eventually it'll shut down, and it'll go back to the idle state. And I'll pass to Andy Tran to introduce the FSM.
So the default state of the elevator is the idle state, and it will stay in the idle state until a request is called upon. There are 4 possible requests, and the cases we chose to implement are in the case of an emergency, and if the requested floor is either equal to, greater than, or less than the current floor. For simplicity, let's begin in the case of the floor being greater than or less than the current floor. And we will go down this tree. When the request is called in this case, the elevator will move slowly up or down depending on whether or not the current floor is greater than or less than the requested floor. At this time, the count variable, which counts down on a timer, is assigned the number 2. The elevator will then accelerate in the desired direction and move into the processing state until the floor difference reaches 0. After, the elevator decelerates, and when the elevator stops moving, it goes into a middle state until the count variable is counted down to 1 from the timer. Once that happens, the elevator doors open and moves into the second middle state, and then the elevator doors close. When the door closes, the elevator returns to the idle state. The other possible case is when the requested floor is the same as the current floor, and if so, then the elevator doors will open, and since the elevator isn't moving, it will go into the second state, the second middle state, and then the doors will close again. The last case is in the case of an emergency. During the emergency state, the emergency light will flash on a timer and then return to the idle state. During any state, if the reset button is pressed, the elevator will return to the idle state and at floor 1. Now I'll hand it off to Ramandeep to explain the board layout.
And to go over the board layout, we'll go from left to right. Starting at the furthest left, we have the buttons going from here. The button 3 would be a simple reset to restart the board. Button 2 would be the option to close the door. Button 1 would be the option to open the door. And lastly, button 0 would be the SOS function. Then we start from this green box highlighted, going from switch 8 to switch 11. Switch 8 would be the request going from inside the elevator to go to floor 1. Switch 9 would be the request to go to floor 2. 10 would be to go to floor 3. And lastly, the switch 11 will be the inside request to go to floor 4. And then we go to this pink box. For the pink box, the switch 0, so similarly, if you were to enter a building, you'd have the option to only go up because there is no ability to go down. So switch 0 is the option to go up. Then we have switch 1 and 2. You're currently on the second floor of a building and you want to go to the first floor or the second or the third or fourth. So switch 2 is the option to go down, and switch 1 is the option to go down, and switch 2 is the option to go up to either the third or fourth. And then the same can be said about switch 3 and 4, which represent being on the third floor. So switch 3 is the option to go down to either the second or first, and switch 4 is the option to go up to the 4th floor. Lastly, we have switch 4, which is the option to go down. Since the 4th floor is our 4th and final floor, you can only go down. From there, you can go to floor 3, 2, and 1. And then to talk about the LEDs, these LEDs detect which floor you're on. LD6 is, sorry, these LEDs are to represent, there's a request for floor 1 or 2, 3, and 4. So this is the request for floor 1. This is the request for floor 2. This one will request floor 3. And lastly, this LED 9 would request floor 4. The red box highlighted, these are the ones that represent the current floor. And so this will be current floor 1, floor 2, floor 3, and floor 4. It's also important to highlight, as you're switching from state to state, these change as well. So if I were to request, so if I was in a moving elevator, it would tell me this is floor 1, floor 2, floor 3, floor 4. And then we have the SOS LED, which turns on when the SOS button is pushed. And then for the 7-segment display, going from left to right, the leftmost 7-segment display would be, this would represent the left door. Next, the second one right here would represent the right door. The third one would represent the arrow from going up or down. And lastly, the last one tells you the floor number. And I'll now pass it off to Sebastian for the demonstration.
So here for our elevator, we can see that the elevator is currently on the first floor, indicated by LD0 and the 7-segment display here. The doors are currently closed, as we can see with the left door and the right door. If someone on the 4th floor requests the elevator to go up, or requests the elevator to go down, the elevator starts moving up, and you can see the request came from the 4th floor. We can see the LED moving from right to left, from floor 1 to floor 4. As you can hear from the announcer, we are arriving at the 4th floor, and the door is opening. After a short delay, the door will close once again. Now that the person is inside the elevator and they're on the 4th floor, they can request the 2nd floor, 3rd floor, or 1st floor from the switches 8 through 11. So they're going to go ahead and request the 2nd floor. So the elevator announces that it's going down. The movement arrow flashes on the 7-segment display, and it counts down to the 2nd floor. The door opens, and the passenger leaves the elevator. Now in the idle state, again, we wait for another person to we wait for another request. So now a person is going to want to go up from the 1st floor, so they're going to hit the up button. There we can see that the request comes from floor 1. The elevator moves back down to 1st floor and opens and closes the door to load the passenger. So now the passenger wants to go to the 3rd floor. They're going to go up here. They're going to hit the 3rd button, and it's going to move up to the 3rd floor. And the doors open, and they close. Now say the person forgot or wasn't paying attention when the doors open and they closed, they can go ahead and reopen the door by pressing the open door button. As you see, it opens the door and gives them another chance to exit. Now let's say this button isn't working and they get stuck in the elevator. They can hit the SOS button, and the emergency button blinks. And now if we wanted to reset the whole elevator, we just press the reset button and it resets it down to floor 1. And that is the demonstration.